That's why I gave it a little calculator. And the whole thing, like mine are super stressed. This type of lost my face.
Wait, but there's still
I've done
I don't know if it's recording or not, so we're just going to start and kind of screw it here.
I don't think it's.
I think it might be.
Oh, yeah.
All right. So here's what we're going to do. We're going to be first starting by using the method of finding square roots. So when you're looking at an equation like this, and this doesn't work when you have a bx term. Notice how there's no bx term in this particular equation. All right? You want to get the x squared term on one side by itself. That's what you want to do. So subtract 10. And I've got 4x squared equals 36. And I want to divide both sides by 4 because I'm trying to get the x by itself. And I have x squared equals 9. Okay? My next step at this point is I am going to square root both sides. Square root here, square root here. Now, when you take the square root of both sides, this actually will give you two answers. This will give you x equals 3 or x equals negative 3. And you have to think about this because 3 is the obvious one, but negative 3 also works because negative 3 squared does give you positive 9. So it does give you two answers, which it should because we have x to the power of 2, which means two answers. So let's go over here to the next one. And we're going to add 5 to both sides. And I've got 3x squared equals 30. Divide both sides by 3 because I want the x squared by itself. And this is 10. And again, you're going to take the square root of both sides. And I can write this x equals the square root of 10 or x equals negative square root of 10. Now, would you agree that's not going to simplify? Square root of 10 doesn't simplify. There's no way to split that up. There is another way to write this. And that is like this. X equals plus or minus the square root of 10. And that means x equals 10 or x equals negative 10. That's what it actually means. Yes?
Couldn't you do that for that first one?
Absolutely, you could do that for the first one. Okay. So the next thing we're going to do is we're going to extend this concept to what is called a perfect square trinomial equation. And this is a lovely perfect square trinomial equation. Would you agree that this side factors to x plus 2, right?
Yeah.
Just looking at it. So we're going to write x plus 2 quantity squared. And this equals 25, right? You would agree. X plus 2, x plus 2 gives us x squared plus 4x plus 4.
Yes.
Okay, well, I can use the same concept and square root both sides. And here's what I get. I get x plus 2, because that's what I get when I square root a square, equals plus or minus 5. Right? Now, I want x, not x plus 2, so at this point I'm going to subtract 2 on both sides, and I get x equals negative 2 plus or minus 5. Now, I can simplify that, so I will. X equals negative 2 plus 5, which equals 3, or x equals negative 2 minus 5, which equals negative 7. A lot of times when you're using this method, you're not going to get nice, pretty numbers like this. You're going to get square roots that you have to deal with. All right, so next thing we got here. What I want to show you here is the method, basically, for completing the square. I love this little diagram here. Basically, what they're trying to show you visually is how to make this shape, which is a rectangle, into a square. Because what you want is this to be a square, because then you can take the square root. And what they ended up doing, this is x squared right here. Would you agree? This part here, x times x is x squared. And this right here is b times x, this is bx. And what we want to do is add a c to it so that the thing becomes a square. So the way that we do that is we're going to take this piece right here and we're going to chop it in half. So each of the little pieces is b divided by 2x, half of it. So this is b over 2x. And this piece is b over 2x. Now you're getting close to a square. And this little section, see how this part is b over 2 wide and this part is b over 2 wide? That gives us this little square that we add, and this is b over 2 quantity squared. And if we can add that little piece to that side, we have something that's a perfect square, and that sets up this formula. So here's the basic premise of this, and you'll recognize it when we do it. I have x squared plus bx. If I take b divided by 2 and square it and add that, it will factor like this. See how each side is x plus b over 2? All right, let's go through some examples. This is that same box on the top of this page. So, here's what I want to do first. Take this guy and get rid of him. So send him to the other side. So, I have 3x squared minus 12x equals negative 6. Now, the difficult thing with this that we didn't have in Algebra 1 is that now we have something in front of here. Do you see what I'm saying? We have an a. You can't have an a. So we're going to divide by a everywhere. We got to get rid of it. We can't have an a. The process doesn't work with an a in it. So we're dividing both sides by the a. The a is 3 in the ax squared plus bx plus c. So here's what I've got. I've got x squared minus 4x, and over here I have a negative 2. Okay? Now, do you see that if you were to move that negative 2 back to the other side, this does not factor. It's not going to work. What I want to put here is b over 2 squared. B over 2 squared. In this case, our b is negative 4. So this is negative 4 over 2 squared, which gives us negative 2 squared, which gives us 4, right? What I would do, instead of writing, you can write the 4 over here. Do you see how it also equals negative 2 squared? Just write it as negative 2 squared here. Even though it equals 4, we're adding it to both sides. Remember, we can add anything we want as long as we do it to both sides. The reason I'm going to leave that alone is because this factors to x minus 2 quantity squared. And where did I get the minus 2? Right there. All right? Over here, I've got equals 2. Now I'm going to square root both sides. So I have x minus 2 equals plus or minus the square root of 2, which doesn't simplify. And my very last step is I need to add 2 to both sides, which is going to give me x equals 2 plus or minus the square root of 2, and that is my answer. And you will find that with quadratic equations, that is not an infrequent occurrence to get square roots in your answer. Okay? So what I want to do is let's go to example B here, and let's see what we can do with this. Remember, we want the bx's over here, and we want the numbers over here. So I'm going to subtract the x to get it onto the left and subtract the 3 to move it to the right. And now I have 2x squared minus 2x, I'm leaving a space, equals 6. You can't have a being anything other than 1, so you've got to divide by it. Everything gets divided by it. So now I have x squared minus x equals 3. And I need to add something right here and right here. And what I'm going to add is b over 2 quantity squared, which is negative 1 over 2 squared, which I know to be 1/4. Okay? Now, when I write it over here, I'm going to write 1/4.
Wait, where's the, oh, b over 2, okay.
Yes. Over here, I'm going to write negative 1/2 squared. And the reason why is because I'm going to use that. This is x minus 1/2 quantity squared. That's how it factors. And over here, we're going to need a common denominator. So I'm getting 4 as my common denominator. That gives me 12 over 4. So I have a total of 13 over 4. And it will give you fractions. You just got to work with it. Now, at this point, square root both sides. Okay? This gives you x minus 1/2. This is plus or minus. Would you agree? The top square root of 13, nothing you can do with that. What is the square root of 4? 2. So we're just going to put a 2 on the bottom. Okay? Now all I have to do is add 1/2 to both sides. And what I get as my final answer is x equals 1/2 plus or minus the square root of 13 over 2. And because I have a common denominator, I can go a step further. I don't have to, but I can. This would be x equals 1 plus or minus the square root of 13 all over 2. Same thing. Doesn't matter which of those two ways you write it. It's the same either way. Okay. Now, next thing we're going to do, we're going to use this same process, and we're going to take an equation that is in standard form, and we are going to rewrite it so that it is in vertex form. And if you recall, vertex form is y equals a times x minus h quantity squared plus k. Agree? Okay. So, here's what we're going to do. I don't want to deal with this 6 right now. I'm going to move it to the other side. So, would you agree, if I do that, and it's only a temporary move, I have y plus 6 equals x squared plus 4x. So far, so good. I am going to add c here, and I'm also going to add it over here, because everything you do, you got to do once on each side. This is b over 2 quantity squared, which is 4 over 2 quantity squared, which is 2 squared, also known as 4. Now, over on this side, just going to add plus 4. Over on this side, I'm going to write it like this, as b over 2 squared. So, and the reason why I'm going to do that is because this is going to factor nicely. So this over here becomes y plus 10. This factors to x plus 2. Where did I get the 2? Right here. Quantity squared. All I need to do is subtract the 10 on both sides, and I get y equals x plus 2 quantity squared minus 10. Now, it says, name the vertex and the y-intercept. So, what do you remember about the vertex?
-2, -10.
It is what? Say that again?
-2, -10.
Yes. It is HK, which is -2, -10. And we actually need our y-intercept. What's your y-intercept? Do you remember how to find that?
10.
No! You find your y-intercept from standard form,
-6.
-6. Y equals 0, -6.